haven't done it. So let's try together. So we will have this comparison between the N-type semiconductor and the P-type semiconductor. So first, is it these two types of semiconductor is pure semiconductor? So therefore, your answer should be your answer should be no. Okay. So this one is no. Both are not pure type. They are extrinsic type. Okay. So next one, the dopant material. What's the dopant materials for the N-type? So N-type, so the dopant material should be the pentavalent elements, or the pentavalent impurity, we call it. And then for P-type is trivalent, okay? Do you get it correctly? So function of the dopant material here. So N-type with the pentavalent, so with 5 electron. Therefore, it will increase the number of electron. This one will increase the number of hole. Okay. And what is the valence electrons? How many valence electrons of the dopant material? Pentavalent, how many valence electrons? 5. And then P-type is 3. Okay. So this one has no problem. And then for this one, majority charge carriers for N-type. What is the name? Or what is the elements electron? Then for the P-type will be the holes. So since the majority of N-type is electron, so opposite the minority will be the holes, and this one for P-type is the electrons. Okay, so everybody can do it. Any problem? No problem. Yes, then very good. So this is the answer. So therefore, what is important here is you must remember what is called this majority charge carrier and minority charge carrier. Okay, because it plays an important role in the semiconductor, right? Okay, next we will look at the diode. Okay. Okay, diode. So this part is to study the characteristic and working principle of diodes. So diodes is a specialized electronic component that is usually used as rectifiers, signal limiters, voltage regulators, switches, signal modulators, signal mixer, signal demodulators, and oscillators. So you can see there are a lot of electronic components that can perform their function by using the diode. So first of all, we look at here. So diode is an electronic device that results from the fusion of p-type material and n-type material. So like shown in this figure. So you have p-type and n-type. In a simple way, we say it is combined together. Then it's form a p-n junction. Okay. This one is to show the material used. So you must use a p-type material or an n-type material. So form a p-n junction. So therefore, inside the p-type and n-type, you have the holes and electrons so that they can flow when this diode is connected to a potential difference. And B shows the what we call it, the symbol. Okay, the symbol of a diode. When you do your practical, so therefore you want to connect a diode in your circuit. So this one is the symbol that you will see. So you have to always remember that diode have two terminals. So one is called anode, one is called cathode. And then you can see the symbol is a triangle. Then here you have one line. So the side with a straight line is the cathode. That means it's a negative terminal. And anode is a positive terminal. So therefore, the direction of the current flow is from the anode to the cathode. So when you connect correctly, then your current can flow from anode to cathode. Or if in the reverse direction, that means this straight line will stop the current to flow through the diode. And then the real component appearance, or you can see in here, this one is more clear. This one, real component. So real component also you can see you have a mark here. Okay, same as for this one and this one. So the side with one mark, that is the cathode. So in actual, so if you want to assemble the components, that means you want to assemble the diode, so you have to check where is the mark so that you can assemble it in the correct position. And still remember that diode, we can either use the silicon or the germanium, these two type of material to manufacture the diode. Usually this type, if let's say you have chance to go to the lab to do the experiment, normally we are using this type. That means look like this, which is the silicon diode. And then this type are the germanium diode. That means the material used. Okay. And then what is means by PN junction? The diode is the PN junction. Okay. A PN junction is formed by joining P-type and N-type semiconductors together in very close contact. As we know, the majority carriers of P-type semiconductors are holes, and for N-type semiconductors are electrons. Therefore, P region has many holes as the majority carriers from the impurity atoms and only a few thermally generated free electrons, minority carriers. While N region will have the opposite, in the opposite way, So N region has many free electrons, which is the majority carriers from the impurity atoms, and only a few thermally generated holes as the minority carriers. Okay, then we see what will happen to the PN junction. So you can see this diagram shows the majority carriers and the minority carriers in both regions, P and N regions. Okay, and then you will see here the yellow area here, which is a thin layer. So this is the PN junction. So this PN junction forms at the boundary between two regions, which is this yellow line. And it is a very narrow region, okay? By referring to this figure, so before the PN junction is formed, there are as many electrons as protons in the N-type material, making the material neutral in terms of net charge. The same is true for the P-type material also. Then the free electrons in the N region are randomly drifting in all directions. And at the instance of the PN junction formation, so the M region will lose the free electrons as they diffuse across the junction. Okay. Before that, when these two are separated, so the electrons are moving randomly inside this M region. So when you put these two near to each other, then this electron will start to diffuse to the P region. And this creates a layer of positive charges near the junction, okay? Then as the electrons move across the junction, the P region loses holes as the electrons and holes combine. This creates a layer of negative charges near the junction. And these two layers of positive and negative charges form the depletion region. Randomly drifting? No. Initially, all these, the electron, they are moving, randomly moving in the N region, same as for the holes in here. So when these two are, these P and N are put near to each other, because one you have more electron, then P has more holes. So therefore they will attract to each other, correct or not? So therefore it will start to diffuse, and you will get a depletion region like this. Okay. So we have to understand what is this depletion region. The term depletion refers to the fact that the region near the PN junction is depleted of charge carriers. That means the electrons and the holes due to diffusion across the junction. Okay, and keep in mind that the depletion region is formed very quickly and is very thin compared to the N region and also the P region. So although in this figure, you can see it's quite thick, but actually it's very thin. So the explanation of it will be here, the formation of the depletion region. All right. And after the initial surge of free electrons across the p-n junction, the depletion region has expanded to a point where equilibrium is established and there's no further diffusion of electrons across the junction when it reaches an equilibrium. And this occurs as follows. As electrons continues to diffuse across the junction, more and more positive and negative charges are created near the junction as the depletion region is formed. Then a point is reached where the total negative charge in the depletion region repels any further diffusion of electrons into the P region. And the diffusion stops. Okay. So in other words, the depletion region acts as a barrier to the further movement of electrons across the junction. All right. And then now we look at the barrier potential, because this depletion region is a barrier for this p-n junction. So there is a barrier potential. So in the depletion region, so there are many positive charge and negative charge here. Then the forces between the opposite charges form an electric field. Okay. Positive charges form an electric field between the positive and negative charges. And then you can see the arrow here, the arrow. So this one form the electric field line. So this electric field is a barrier to the free electrons in the N region. And energy must be expended to move an electron through the electric field. And the external energy must be applied to get the electrons to move across the barrier of the electric field in the depletion region. So the potential difference of the electric field across the depletion region is the amount of voltage required to move electrons through the electric field. This potential difference is called the barrier potential, and usually we will express it in the unit volts. Okay, so that means you have to apply an external voltage. That is so that these charges can further move to the P region. Okay. So what is the limit of the voltage required to enable the charges to further move is called the barrier potential. So usually for the barrier potential for the silicon diode and the germanium diode is already fixed. Right? So for silicon diode, usually it is we say is 0.7, normal in a normal way, and then germanium diode is about 0.3. And the explanation of this barrier potential, what is the meaning of the barrier potential? Okay. And next one, we will look at the biasing of the diode. This one is an important term of the biasing of diode, because a diode you have to bias it so that it can perform its function in the electric circuit. So biasing is providing minimum external voltage and current to activate the device to study its characteristic. So there are 2 operating regions and 3 biasing conditions for the standard junction diode, and they are, so 3 biasing condition, 0 biasing, then second one is the forward biasing, and third one is the reverse biasing. So if zero biasing is very simple. That means we are not connecting the diode to any external supply. That one is called zero biasing. Okay. So this zero biasing is also called the unbiasing diode, right? So that means if no voltage supply is applied to the diode, so nothing will happen. Second one is the forward biasing. So forward biasing is one of the most important, a very important biasing condition for the diode. So if P region is connected to the positive terminal of external DC source, okay, and N region is connected to negative terminal of DC source, so this diode can be said to be forward biasing. So you can see anode of the cathode connect to the positive terminal, and cathode of the diode connect to the negative terminal of the battery. And then we always have a resistor connected in the circuit to limit the current so that it won't damage the diode. Then the bias voltage, okay, must be greater than the barrier voltage. So as I mentioned before, for germanium diode is 0.3 volt, and for silicon diode is 0.7 volt. Or sometimes you look at some reference book, they will give you in a certain range. For example, maybe it's for germanium 0.15 until 0.4 like that. Or silicon is 0.6 until 0.7 or 0.8. So this is the range. So this is what happens when the diode is forward biasing. So the diagram shows that what happened. So you can see here, due to negative terminal of external source connected to N region, so electrons are pushed towards P side. because here is negative, here is also negative. Therefore, it will try to push the electron to the p side. And then same as for these, the holes here in the p region, because here is positive terminal, and this one is hole positive. So therefore, it will be pushed to the n region also. Hence, a large number of electrons and holes can cross the junction under the influence of externally connected DC voltage. Okay, and due to this, the width of depletion region will reduce. Okay, because all of this will be pushed, positive push here, negative push to n. So therefore, the region, the depletion regions become smaller. Right, and then the holes converting into the positive ions into neutral atoms. Okay, and holes converting into the negative ions into neutral atoms. So for this positive, not positive, for this forward biasing, the bias voltage source will impart sufficient energy to the free electron, so that for them to overcome the barrier potential here and move on through the this depletion region. Okay, so when all of these positive charges, negative charges, and they can move through the depletion region. Okay, so therefore the electron here also can be moved, and then the current can move through the diode. Okay, not move through, the current can flow through the diode. So the features of forward biasing is that when the diode is in forward bias, so it will behave as a low resistor, because current can flow through it. Normally, a low resistance current can flow. So therefore, the diode behave as a low resistor, and then the current is mainly due to the flow of majority carriers across the junction. And the potential barrier and the depletion layer is reduced. All right, because in original condition, this number of positive charges and negative charges at the depletion region is in an is equilibrium. So when supply voltage applied to it, then the depletion layer is reduced, and all the charges can cross through it. So in reverse biasing, if P region is connected to the negative terminal of external DC source, and M region is connected to positive terminal of DC source, is said to be reverse biasing. The reverse biasing adds the internal film. So during reverse biasing, so cathode connect to the positive terminal and anode connect to the negative terminal. So this process widening of the depletion region. Okay, and you can see the depletion region here will be widened because the charges of the elements in the N region, which is electron, and here is positive terminal, so therefore they were moving into this direction, the electrons. And then same as for the p region, the holes moving to the negative terminal direction, and therefore the depletion region here will be widened. And during reverse biasing, the diode behaves as a very high impedance element, or in a simple way we can say it is like open circuit. So the depletion layer width is widened and the barrier potential is strengthened. And you will have a small current flows across the junction called as reverse current. Usually for germanium, it is about few microampere, and silicon is in nanoampere. And the further rise in the reverse bias voltage to a value called breakdown voltage, the reverse current will drastically increase and causes the collapse of junction barrier called breakdown of the diode. Right. And when the diode is in reverse bias, so if the reverse bias voltage is increased beyond a certain value, then a rapid increase in current will occur. This critical voltage is the breakdown voltage of the junction. Then there will be two effects responsible for this breakdown, which is called the avalanche effect and Zener effect. But for these two, we will further study it in the in the next two chapters, which is the Zener diode. Okay, because the Zener diode is also one type of the diode. Right. This one is a tree diagram to show the connection or the relationship from the semiconductor physics. Then we will have the silicon and germanium. Okay, the properties of the silicon and germanium enable it to dot with the pentavalent or the trivalent, so that they can form p and n type materials. And then when p and n type materials are placed very near to each other, they will form the p-n junction, and then this one can be used to construct the diode. Okay, and p-n junction, so important is the forward bias and the reverse bias condition in the p-n junction that enable it to perform in the diodes and also the transistor. Because of this forward bias and reverse bias, so this property can make the diodes to act like you want this time it become on, and then another time it is off. So therefore, after that, you can use it to use the diode in the power supply circuit, like the rectifier circuit, and also the voltage regulator. And one more is the clipping and clamper. That means you want the output voltage to reach a certain level, so you can use the diode too. And before that, didn't have here. Let's see. This is how should I show you? Present a window. This one bring it here. Okay. If I want to show you a video, how to do? Because right now you cannot see. Just wait, I want to show you a video. And now I'm trying.
Okay.
I share a Chrome. No. Share a window. I share you a window. Can you hear the sound? The video?
Yes.
Yes, sir.
Miss,
So
your
then
chat didn't scroll down.
Don't.
my chat scroll down.
Joe, we asking what is the difference between drift and diffusion just now for the P and N?
Drift, that means it will, how to say, moving slowly, yeah. Okay, the slow movement of the electron, or the hole, okay. And then diffusion, meaning that it will be like forced to cross somewhere, because of the concentration of the electron in the M region, and then it will force to cross to the P region. So that one is called diffusion. All right. Does this thing apply to solid state drive? It's applied to all solid state, most of the solid state electronic component. Okay, is it okay? So the drift, that means you have the electron moving slowly, yeah. And then if diffusion is due to the concentration, then it is forced to move to another region. Then we can see here the video from the YouTube.
Are you playing the video?
Can't see the video and the
Or we can't see
audio
the video?
is not that clear,
Huh?
Yeah.
Audio is not clear.
and we can't see the video.
Yeah, yeah.
Huh? Can't see the video.
Yeah.
Wait, can't see the video. No, I share it using window. You can hear but cannot see, is it?
Yeah.
Yeah, yeah.
Oh, yeah, and
Mm.
the audio is from your mic, not video.
Oh,
Yeah.
I see. Should I close my mic? Not,
No, I think.
PN junction and diodes. To increase the practical utility of a P or N-type
Class. Sorry, huh? Now can you see my screen or not?
Yes.
If I open this one, can you see?
Huh?
Can see, It's a YouTube. Can you see?
Yes.
No.
Some yes, some no. Is it? Is it some
I
yes,
don't
some
know.
no?
Are you playing the video or haven't yet?
I'm not playing yet. Now I
Yeah.
play. Can you see or not?
Yes.
Right now I'm playing. Can you see or not?
Not.
No.
No.
Okay, so how to share?
No.
No. Then I try one more time. Sorry. Alright. Let's share this time. Now this time try.
Yes.
Is it
Quite laggy.
is a
And
mainly
already.
resistive nonlinear
Can already, yeah?
electronic component with
Audio
two
very
terminals
laggy.
whose function
Yes, what's the problem?
Audio laggy.
Oh, audio lagging. That means I cannot show you the video through the meeting, right? So all is to show you. I just put in the Google Classroom the link, and then you go and watch it. Is it correct?
Yeah. Okay.
Okay. So at the end of this class, so I will post some a quiz for you to do it. Then everybody can take part. It is a multiple choice question. Right? Is it okay?
Okay.
Okay. So therefore, let me see. Do I still have some? Okay. Diode. This one is some diode measurement. But right now you cannot see my screen, right? Can you see? Cannot see, right? Can you see my slide?
No.
No. No, that means every time I have to change here, change there. Is it? Oh my God.
Yes, you can choose the option to share your entire screen, so it's easier. No need to change one by one.
Yeah. Oh, because just now I'm trying the video, so I use the Chrome tab. So right now is the entire screen. Okay. So this one is the diode. Okay, diode symbol. And the connection. Actually, if you look at the diagram like this, do you understand what is happening? How to do the connection or not? So this one is a battery, okay? Then connect to your diode, right? And diode is connected to a lamp or a LED, all right? We say it's a LED, yeah? Actually, LED is also one type of a diode. It's called light emitting diode. And then connect back to the negative terminal. So this one is a very simple test to check whether your diode is functioning or not, or your connection is correct or not. Because if you connect your diode in this way, so what will happen? The positive terminal connect to the anode, then negative connect to the cathode. So your diode will be in the forward biasing. When forward biasing, so your diode here is a low, behave as a low resistance. So therefore, or sometimes in a more simple way, we say if forward bias is your diode is like short circuit, all right? So therefore, because 6 volt is here, it is more than the barrier potential of the diode. So therefore, current can flow, right? So your LED or your bulb, you want to say it's bulb, can light on. And when you go and do the measurement, okay, using the multimeter here, so you can see the voltage across the diode is 0.7 volt. This one is the potential, barrier potential of the diode. It will always stick to the 0.7 volt. So therefore, the voltage across the buck will be 5.3 volt. All right. So these two add up together equals to 6 volt. So this one is for the diode multimeter checking. So connected this way across the diode, the meter should show a very low resistance. So this one is in the forward biasing, and connect in this way. So when the diode is open at like open circuit, so it become a very high resistance. And then just now, what is this? And this one is a special diode check function which display the actual forward voltage drop of the diode in volts. Of course, this one have to be used, the multimeter. So if at home, at this time, you cannot do the practical, the hardware practical, so you will just do the simulation. This is for chapter 2 where diode is used as a rectifier to rectify the voltage like this. All right. Okay. Some connection. Does diode have resistance? It might have a very small resistance. Normally, we can neglect it. All right. So I have to see whether it is forward bias or reverse bias. Okay. It will be different. The internal resistance. You can say it is an internal resistance. Right. But normally, if we do calculation, there will be three mode or three model we can consider. First one is the ideal model. Ideal model, we just assume that the diode is either how to say, when forward bias, the diode is short circuit. That means 0 volt. No voltage across it. Or in practical mode is this one, 0.7 volt. Or another one is complete mode. That one is in the reverse bias. We will consider a resistance appear in the diode there. Okay, a small resistance on the value. Okay. Any other question? If no question, later I will post the multiple choice question as a quiz for you all to do. All right. So it's okay. Can upload the syllabus. Okay, later I will do it. Syllabus, you want the main topic. Because I only listed down all the main topic. Every main topic. Okay. No problem. And reference book. Okay. Anything else? Let me put down. So you want the main topic syllabus? Reference book. Then the duration of the quiz is by this Friday lah. Okay, because everyone you only have one chance to do it lah. Okay. So if there's no more question, then we can end the class now. Is it okay? Okay, thank you, class.
Sure, you post the quiz right now.
Not yet.
Oh,
Not yet.
When's the due date for the quiz?
This Friday.
This Friday. Okay.
Okay. So thank you, class. Thank you,
Thank you.
student.
Thank you.
And goodbye.
Bye. Stay safe.
Stay at home.
Jangan ke sana ke sini ya.
我也是老师翘。
Ciao dia.
Ke sana ke sini.
小课是做了讲一下，小吃过。
跟我好像没有差别，你知道吗？他就太低了嘞。
这不想笑。
我没有在叫，我已经没有在叫，你知道吗？
Hey guys, when's the quiz?
Later she post. Yeah, Friday.
Friday. Okay, thank you.
为什么 Friday for quiz or she
刚刚的 dial 的东西。
我现在已经在妈妈喝茶了。
你在妈妈喝茶，我本来有人开 notes 准备抄他做 notes 的，知道吗？然后扣还一直在里面念，我的 fuck it， 我直接丢我说，然后我直接开我的那个 WhatsApp， 然后全部在那边聊天哦，我在那边心想，哇，全部人直接不用上了，我说你还真的在妈妈？
我个这
我们没开玩笑，我从头到尾在上课。
哇，good effort。
Okay, goodbye.
拜拜。
拜拜家里。
拜。
就是要玩 game 啊。
When you want buy your laptop?
什么？What 啊
When you want buy your laptop?
你讲做那个 online 的那个 ebook。
Your laptop 啦。
什么东西
？Sunday。
你讲
哇，Sunday 啊，so fast 啊。
OK。
My XPG.
我定。
就你讲拿 reference book 啊
reference book
不懂要买的嘞。
online 找。
internet 咧。Internet library。
Our school give
我可以 send 给你们那个 electronic 的书啊，放在 group 要不要？你们要
？Yeah, sure.
哦，send what also send？
哦，对，那个sensor and actuality 的那个星期
sensor 我没有看，我忘了 sensor 我没有。
然后这个星期的课好像没有，就给 replace 掉。
所以是 week 3才开始还是什么？
对 ，week 3才开始，一开始是讲下个星期的。哦，wait， let's explain in English.
I understand 啦。
understand 啦。
Understand 啦。
actual and sensor.
Sensor and actuator.
Sensor and actuality.
就是2 MB 的书啊。
Yeah, and then they actually the mechanical class they available time for them is Monday 1 p.m. to 3 p.m. which you guys cannot. You guys have engineering material, and then Wednesday 3 to 5, and another Thursday 3 to 5. Which one you want? Wednesday or Thursday? The time is 3 to 5.
But after week 3, go back to normal, right?
Yeah.
After we just replace the class only.
Shit.
Or you guys want me to apply for, but then I don't think we can separate class. Like I want to separate class with them. Like I don't want to like take same class with them, man.
I don't want to noisy 的哦。
对啦。
Man，
那个 quiz 拜5啊，是老师直接给还是他 给我们
等下他才会给。
什么？
今天他会给，今天他会给。
然后只能回答一次吧。One time answer。
就是那种online quiz。我明白了。
对，
我们可以去找我们
multiple answer question 来的。
那 multiple choice question。
multiple choice question。
这样子可以啊，去上网找吗？这
Just copy only Everyone do one question.
How to copy ABC also want to copy
Yeah lah, copy lah. You do one question, I do one question, everyone do one question lah. Settle.
Oh yeah. Our
yeah.
Check
this year
那个 quiz 应该1个小时吧？我们如果开始做的时候，所以如果要一起做的话，就要讲先。
Anytime.
anytime.
Until Friday.
Before Friday, you need to hand in 10 already.
Wait, so how? The sensor class until week 3 only go back to the normal or how?
Not week 3, this week. I think it's this week. The teacher didn't say when, no, that's the funny part.
Tomorrow.
So week 3 they will be normal lah.
Mm.
So week 3 will be Friday lah.
Do you wish to place a class for tomorrow? I need to verify the water. Blah 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 blah.
Yeah, it's sleeping ah.
Amil, they didn't say anything. They didn't say when.
I was him.
No leh.
Oh, he's back.
Oh.
Back.
So tomorrow class as usual. Okay.
Yeah.
Tomorrow one only meh? Not got 2 meh?
One cancel. Aduhai.
Cancel forever.
Week 3 continue.
Sad ah. I thought cancel
Wait,
forever.
so Friday cancel lah.
Wow, you got time to go out. I don't have
Friday
time.
got
Friday got not. So only the Thursday one will have.
Wait.
Friday is got 2 group mah. Yeah lah, that's why I asking. So Friday got not. Yeah lah, but later got not. He cancel not. I thought he cancel Thursday only.
Yeah. Gmail say cancel Thursday only. Yeah.
Huh. So
Yeah.
they only cancel replacing for
You
one
the
class
one who
only lah.
didn't read the Gmail.
Yeah lah, you.
So it's
Yeah.
Thursday, right?
I
Yeah lah,
think
we
so.
only replace for Thursday lah. Huh?
It's okay lah. Friday is 11 o'clock one.
Wow, then that means
11 o'clock for our group lah, huh?
That means
Yeah.
Thursday only got one engineering material. Hey,
Yeah.
who engineering material at Thursday? 5 to 6 o'clock.
Me.
Hey, let's go.
Everyone lah, lecture lah.
Lecture?
Yeah.
Lecture lah.
Like today one.
Then my one is Friday. Friday, 8 to 10
No,
o'clock.
I got one person. Who ah?
Practical. Yeah, you know, right? You know, like Friday.
10 PM.
One, 3 to 5 here.
How class I think his one is Thursday morning lah.
I want to achieve my walking time.
Wait, Desmond. My XPG.
SPG.
Okay lah, I'm gonna go eat
Yeah.
first. Ciao, guys.
Bye.
No, the one I sent in the
Bye.
group one.
SPG. You got send
Yeah.
Okay, 我走先了，大家拜拜。
What the hell?
Bye.
Xenia Gaming Notebook.
Hey, buy the Boston Robotics robot.
Fuck you.
Only 75k USD what? Yeah lah, you can buy 2 Tesla only mah.
Walao eh.
What the hell? What brand is this? XPG.
Adada one.
Yeah, Intel. Yeah.
Intel driver good what?
Pricing, let me see.
I see Taiwan got people review it like 5K only.
Wow,
With
only
32
5K.
gig with 1 terabyte of SSD.
Then
Yeah. Because all their things XPG
wait,
things
3K.
so they just put in
5K for
only
which model? The RTX or GTX?
I think it's GTX. I think lah.
Jangan
Not sure.
Illegal RTX 5K leh, 9 je lah you.
But you got 32 gig or not? You got 1 terabyte of
32
SSD
gig,
or
lah,
not?
who wants 32
NVMe.
gig? Who wants 32 gig?
Yeah.
RTX for laptop useless lah. Ayo, Joseph angry later. Useless lah. The screen so small, you cannot even realize RTX on.
Yeah lor.
Yeah, I think I can afford lah, dipshit.
PS4.
PS4 still lagi mah. Supposed to be for school fee mah.
Then buy PS5.
PS4 shit leh.
Plus speed
iPad
5
lah. You see how useful an iPad? Without iPad, I can't do shit, no. You can, you don't have iPad, how to do Photoshop shit?
Multisync can lah.
Huh? Multisync
No,
can,
the
eh?
online
Can.
one. The
Can.
online one. Online
Can.
one can. Only the AutoCAD
Can.
one.
Yeah. Open the USD.
Then you
iPad can
try everything web based one lah.
Yeah lah, anything web-based iPad can do lah.
Yeah.
Basically, most of the things lah. Google Docs, everything lah. Yeah, you, the
Microsoft
game,
can
still buy
lah.
iPad, never buy also.
Surface.
Surface shit lah, the processor. Overheat issues and all. It's a, what I call it, Ultrabook. Pui. Screen on time only 5 hours, then die already. iPad screen on time 14 hours yesterday. Good notes lah, doing all my mathematics lah,
No,
14
working
hours.
phone. Using iPad. Bigger and better.
Bukan hack bodoh, seriously 14 hours. iPad mah, only use for taking notes and YouTube. 14 hours lah. If gaming, screen on time 10 hours lah. Who plays game? People play like Fortnite or could we stream game or something like Nvidia?
这横跨
the
VRAM
cloud-based
及
one.
CPU。
No,
Yeah.
Taiwan. This one is Taiwan people.
Aiyo.
Actually, this the person buy many second-hand stuff. So he really can help you construct a desktop very cheap one. He know everything all laptop desktop things.
Oh, SP. Oh, they go do SSD one, the SSD good one,
Yeah lah. So
Yeah,
they
SSD
just
very good.
buy a computer, then everything put their things, so that it will be very cheap lah for the storage and the RAM.
The SSD, what's that? Comparable with the Samsung one,
Walao eh.
How much you buy? How much?
Fuck you.
For how many gig? Okay leh. Okay what? Okay what? But RGB no, confirm no RGB.
Hey,
RGB or extra FPS.
Faris, you go buy 8 terabyte of NVMe SSD.
Oh yeah, bye.
You got saw Linus review, right?
Yeah. And you see so fast, right? What the hell?
512 gig of cache.
Walao eh. 512 gig cache, you know. My laptop also I don't think I don't
Okay
know.
lah.
You don't even think 8 MB, oh. 512 gig cache, what the hell, eh?
I'm still thinking of buy the Western Digital one, the SN550 one.
Why buy why don't buy Seagate?
Huh? Don't want.
Sig-
Seagate more expensive.
Huh?
More expensive. I
Expensive
buy
but
Western
reliable.
Digital. Western Digital also reliable, ma.
Got
I
problem,
think
I don't know why got driver problem sometimes, what?
sometimes. I want everything fast.
Why? If got people recording at 8K, if people recording
Huh?
8K, of course they want lah. Yeah lah.
Depend how you use also lah.
If for Linus, important lah. He got 8K footage ma.
Yeah.
He use hard drive for archive, but when
SSD.
transferring is SSD. NKBHD ah. Yeah. But that one is for archive only. But for his server, he using SSD, right? Crazy, right? 120 terabytes of SSD. In 5 years, lah. It says the same guy.
No, you got see the RAM one ma, 1 terabyte of RAM. Ma.
You took for lecture only. Later get someone there, you know. Yeah, what's that basically?